So let's make a valid proof. Proof, there it is. Gosh, that was stupid. So we're trying to prove that for all x in the non-zero rationals and for all y in the non-zero rationals, x or y is the non-zero rationals. So we're trying to prove a universal statement about infinitely many things, right? Because there's infinitely many rational numbers, the fractions. And our two ways to do that are method of exhaustion or direct proof. Method of exhaustion, totally out here, right? Because we're trying to prove something about infinitely many things. We don't have that kind of time to prove. We don't have that kind of time to write down infinitely many cases. So to use direct proof. And remember the idea behind direct proof is that you just consider any arbitrary element in the domain and show that the property of those things being in the domain must necessarily lead to the property of what you want. In this case, x or y being q star. If you do that for any old element in the domain, that means it must work for every element in the domain. So what we're going to say is wow, I need to work on my L's, my E's, and my T's apparently. Let's say let x and y be arbitrary but particular elements of q star. And note, by the way, that arbitrary, that just means they're any old elements. Like, you can't assume anything special about them other than the fact that they're in q star. Anything that we assume about x and y should be true for everything in q star. That's the only thing we know about them. But particular means that they are an element. Like, we're going to pick one. We don't know what it is, but it's one. Yeah. And elements, by the way, if you would talk about this, elements is just what you call things in sets. They're called elements. Like how you call people that go to Virginia Tech Hokies, just a name for it, right? Yeah. A great name. But anyway, so blah, blah, blah. Yes, so yeah, this is the setup, right? So x and y are particularly arbitrary elements of q star. And we're trying to prove that just this property of them being q star is going to lead to x over y necessarily also being q star. All right, so let's check out what's the property. What's this give us? Like, what does them being in q star mean? What are some properties of that we can take advantage of? Well, remember, like we said in the scratch work, q star means you're in the rationals non-zero. So, in particular, you're a ratio of integers, which you get that whole definition there. And by the way, I'm just going to write down the side here, just so we have it. Q, by definition, is the ratio, any ratio A and B, where A is in Z, B is in Z, and B does not equal 0. All of those guys. All right. So first things first, if you're in q star, thus x and y are in q, and x is not equal to 0, and y is not equal to 0, right? That's what it means to be in q star, a rational number that's not 0. And I'll say, yeah. Then, since x and y are both elements in q, by definition of q, there exists, I was going to say integers, but I say there exists A, B, C, D in Z, such that B does not equal 0 and D does not equal 0, such that x equals A over B and y equals C over D. Right? Because that's what it means to be a rational number. It means that you can be written as a ratio of integers where the bottom, B, and D, or the B, bottoms or the B's and D's in this case, are not 0. That's a thumbs up to nobody. Hope you're having fun. So yeah, so the point is, this is what it means just to be a rational number. Having the property that you're in q star means that you must have the property that you can be written like this. But in particular, you're also not 0. right? So what that means is this will become important later when we start doing our proof, right? It was important to us that A and C don't equal 0. So what this means, so let's note, right? If A would equal 0, then X, which equals A over B, which equals 0 over B, which equals 0, or then X would equal 0, which is not the case. Similarly, I say that word weird, similarly. That's how I spell it, similarly. Similarly. Oh, that was my chance to redeem myself, and I nailed it. Similarly, if B equals 0, nope, I want C. If C equals 0, then Y, which equals C over D, would equal 0 over D, which equals 0, which is not the case. The point is, right, what we have here, this is actually kind of like, what's going on under the scenes here is, this is modus tollens, right? So what I want to conclude, I'm sorry. So what I want to conclude is that if A equals 0, since that if A equals 0, that would mean X equals 0, and we know X isn't equal 0. That must mean A couldn't have been 0 to begin with. So thus, A does not equal 0, and similarly, B is not equal 0. The intuitive idea being that, I'm sorry, C, and C is not equal 0. The intuitive idea being, and once again, if C was 0, that means Y is 0. We know by definition of Y being Q star, Y is not 0. So C must not be 0, because it would lead to something we know is not true. And this is exactly what like modus tollens is or contradiction is, right? Because this statement right here, that's saying this is a true thing, that A equals 0 implies X equals 0. But we know from this statement right here, not X equals 0. Therefore, not A equals 0. Right, we're using modus tollens here. Or we could use contradiction, which is the argument that goes, A equals 0 implies false, because it implies X equals 0, which is false. Therefore, not A equals 0. Because it couldn't happen because it would lead to something that's false. Anyway, we don't need to write that. The point is, this happened under the hood. So, yeah. So we know A is not equal to 0 and C is not equal to 0. So we know that A, B, C, D are integers, and they're all non-zero, right? B and D aren't 0 because they're the denominators of a rational number, right, which can't be 0 by definition here. And then A and C can't be 0 because by kind of this modus tollens argument we did under the hood, if they were 0, that will lead to X and Y being 0, which they're not by definition. Okay, we got this. I'm sorry. I'm talking in circles because I want to make sure we got it. This really all makes sense. Then, we're basically almost done this. Almost done now. So now, consider X over Y. X over Y equals A over B over C over D by substitution. And then A over B divided by C over D, that's just going to equal A over B times D over C by fractional division. The whole flip and multiply business, right? We're not assuming we know how algebra works, right? Like I can take you through the proof of this, but we don't need to. And then this would just be AD over BC by fractional multiplication. All right. So, what's next? So, sorry about that. So what we've just done is we've shown that x over y equals AD over BC, just like in our scratch. But now we need to show, what do we show? We're trying to show x over y is in Q star. So we need to show that AD over BC is in Q stars, where this is all leading. Now being in Q stars means you're a rational number that's non-zero. So first it starts with a rational number and then show it's non-zero. So to be a rational number, you're a ratio of integers. If we do a ratio here, AD in the numerator, BC in the denominator, so all we need to show is that AD and BC are integers themselves. So I'll say note, since AD, or I'll say A, B, C, D, and Z closed under multiplication as a fact, AD is in Z and BC is in Z. All right, so AD and BC are in fact integers. So to be a rational number, all we have to prove is that AD over BC such that BC, the bottom, the denominator BC is non-zero. Because then we get undefined, that's no good. So this is going to go up here. Further, since B does not equal 0 and C does not equal 0, BC is not equal 0. Thus, x over y, which equals AD over BC, is in Q, right? Because it's a ratio of integers, AD and BC, and bottom's on 0. So now we know that x over y is in Q. We're so freaking close. But we don't want to show that x over y is just in Q. We want to show it's in Q star. That proves that Q star is closed under multiplication. So now just being Q star to show that's non-zero. And being non-zero all depends on AD. So I'll say, finally, note that A does not equal 0 and D does not equal 0. Thus, AD does not equal 0. And so AD over BC does not equal 0. Right? Yeah, I'm comfortable with all this. Yeah, so AD over BC cannot equal 0 because A and D themselves aren't 0. That's the only way you're going to get 0 here. Therefore, x over y, which equals AD over BC, is in Q and non-zero. So xy is in Q star by definition of Q star. And put a square on it because we're done, right? All we've shown, so what we've shown here is that for any arbitrary particular x and y you pick, the ratio in Q star, the ratio x over y will be in Q star. And since it works for any old element in Q star, it must work for every old element in Q star, right? So this works for everything, meaning Q star is true. Q star is truly closed under division. No matter what two elements of Q star you pick, their quotients will be also in Q star. Any questions? Sad that I can't answer, but you can always email me questions with the lecture or anything. My virtual door is always open. I just struck the green marker again. There we go. Virtual doors are always open. But that is class, everybody. Good job. I wish I could get further today, but in the live lectures or the live recordings, I kind of got hung up. I had technical issues, so couldn't do the third proof I was planning on. So we'll end it there too for you guys as well. And we'll pick it up on, what's that day? We have class Monday. All right, well, good luck on your test, everybody. It's due. You're probably watching this. Who knows when you're watching this? Maybe you did the test a week ago. Maybe you watched this really early and it's due in like a couple hours, or maybe it was due today. Either way, hope your test went well, and I'll see everybody later. Stop share. Stop recording.